I'm going to record so I don't forget to record.
Yeah,
And
no worries.
I'll just open up the recording and say, this is the recording. We're going to wait like 10 to 15 minutes until people pop in, and then we'll hammer out some questions, and hopefully everybody can chime in on what they're confused about, and we can all figure out stuff together. So I think I'll officially start at, I don't know, like 5:10. Does that sound, or 6:10? Does that sound good to you guys?
That works.
Sounds good then. Okie dokies. It seems like it's 6:10. So I'm just gonna get started now, and hopefully people can join in later. Um, yo, if you don't know me, I'm Gabriel. I haven't met you before, Nathaniel, so it's nice to meet you for the first time, like face to face, I guess. Um,
Nice to meet you too.
and good to see you, Matthew. Um, yeah, I was just wondering, like, we could all, throw in what we think is going to go on for the midterm, and then maybe we'll hammer out like some home. If anybody like is like, I got the homework right or got the homework wrong, and like still doesn't know why, we can go over that, and then maybe like do some general theory stuff. If that sounds good to you guys.
Yeah, sounds good.
Cool. So starting off with the first thing of like what the midterm is going to be, we were kind of talking about it before the recording, I think. But basically on the slides, it says like there's two parts, and there's theory and problems. And I was wondering what kind of theory do you think, like, I mean, probably compiler phases is my guess, and a little bit of like compiler versus interpreter, or this versus that kind of questions. What do you guys think about that?
Sounds about right.
Gotcha.
I'm trying to find the old homework right now. My bad.
Oh, you're good. You're good.
You
No
didn't
rush.
post any kind of study guide?
Nope.
No, not really. So what I threw something in the chat. It's lecture 12, and he does his own like semi-study guide from slides. I think it's 26 to 70, and that's basically what I've been going off of. It looks like this once you see it. I also got to scroll to it, so give me 1 sec. And everybody has the same properties as host, by the way. So if you ever need to share your screen or anything, feel free. Let's see, we did tail recursion, this one. So it says midterm, it's 29. So midterm review, and then you just go down from there, and that's kind of like the whole thing of like, it goes over each chapter and like the highlights, like key stuff. So that's kind of where I was getting the idea of the compiler versus the interpreter. And do you guys see my screen, by the way? I just realized.
Yeah, we can see.
Okay, cool. Yeah, and like assembly, like we all know kind of what high language and assembly stuff is. I think just because CS 219 kind of talked a little bit about that. This is the only thing I'm really I'm really trying to remember what goes on the front end, because it says on the third I don't know what to call that phase, I guess, semantic analysis and intermediate code generation. And I remember a question on homework 1, part 1, where it said static semantic analysis versus dynamic semantic analysis. So I was wondering, like, because it seems like that's both in the front and the back end. So I don't know, like, if he'll ask anything kind of about that. I mean, that's kind of gray area at that point, but you never know. Do you guys know anything about like the static or dynamic semantic thing? Honestly, do you even know like what it is? Because I'm trying to find a good definition. I can't really, explain it without like Googling it or like trying to.
Was it actually about the analysis, or are you talking about the question from problem 1 that was like describe a dynamics and static semantic error? Because that's
it was like describe it. Yeah, that's what I mean. And like what are examples of it? Like I got that one right only because I kind of Googled around. But like I'm trying to think of like what other examples were. I think dynamic was like accessing.
Accessing outside bounds of arrays is what I had, and so I think it's more along the lines of like it's semantically it makes sense and it works. It's just upon running it, it becomes an error, because that's what's causing the main issue is the logic behind it and not the actual code that was given.
Gotcha. So it's actually like during. So that makes sense because it said when I looked it up on Google, they were saying that it was. I'm sorry. Dynamic semantic analysis was using the interpreter, and on the back slide here it says that the interpreter is going with the source program at execution time. So that makes sense.
Right.
That would kind of go hand in hand. So I'm gonna actually write that down. What you just said.
I think typically speaking, whenever the word dynamic is being given, anyways, it means that it's during execution.
Okay, so then probably we could assume interpreter.
Right.
Gotcha.
Like it may be at a different stage though. So I wouldn't necessarily say just outright dynamic equals interpreter, but in this case,
Gotcha.
absolutely.
Okay. So then
I'm reading, by the way, I'm reading something that says some of the static semantic examples include whether all variables are declared, whether functions and methods are called with correct calling sequences, whether assignments are type compatible, what the type is, which declaration applies to which variable in the case of scoping. So
Gotcha.
it
So
just
that,
seems to be stuff that like even if you don't run the program
Hmm.
and you're not like actively doing anything, you can still check for.
Gotcha. So that seems like compiler stuff then, because it's like doing it before it actually executes it, or is that kind of like?
I believe so.
Okay.
Like
Yeah.
that's the way that I've been thinking about it, because it seems that like because both of them being semantic errors is that something is wrong with how it's written. And so I think the static ones just more so mean before it before you even try to run it, the compiler will be like, there's something wrong here. You gotta
Gotcha.
change it.
Because for the one I did for that one was I had like a function that was void, and I had it like return an integer, and then I really like I just threw that in there because I was like I found it on Google. I was like, okay, but I don't really understand why that would be, but that makes sense since Matthew was talking about data types. That makes a lot of sense now, about returning the proper data type and such.
Yeah.
Gotcha. Can you read that list one more time, Matthew, just so I can get that down? Or maybe share your screen.
Yes. Let me get back to it real quick.
Gotcha.
It's just as including data typing, whether all variables are declared, which declaration applies to which variable in the case of scoping, what their type is, whether functions and methods are called with correct calling sequences, whether assignments are type compatible, etc.
Gotcha. Okay. And then since we're on the topic of homework one, did you guys have any like main stuff you wanted to go over, like check out, like grammar versus I can't remember what the other thing is, but grammar versus the other thing, regular expressions.
So regular expressions are the ones with like you're essentially grouping things and repeating the like characters that you're using, right? Whereas the grammar is actually setting the steps.
Yeah, so like this is like grammar, like here.
Right. Okay.
And then I think he gave an example. Maybe he didn't. Maybe he didn't do an example. He didn't. Oh, there we go.
Oh, there it is. Yeah. Okay.
So yeah, that one. It doesn't seem too bad. I mean, at first when I first did the homework, it was really hard. But like going back on it and working on some of the problems, I mean, maybe because it's the same problem, but it didn't seem too tricky.
I think in general they're fairly decent. The grammars are at least easier to me just from the fact of splitting it up makes more sense than having to just write out one thing.
The tricky thing is, and I think he might ask this too on the test about ambiguity. It was up here somewhere. And once again, feel free to share your screen if you guys see something.
Oh, like making a grammar unambiguous?
Yeah, because you can't really do that with regular expressions, but with context free, you totally could. So that's a little tricky. And then I don't really understand what's going on with this parse tree here. Like, is he just saying like, oh, never mind, I see it, because he's just saying an S could be broken up on the right side versus on the left side, because they're the same thing. Okay, cool.
You could essentially end up with the same thing no matter which route you take, and that's an issue.
Yeah. Okay. He might. I totally think he's going to quiz us on some like non-terminals versus terminals, and how I think of terminals is it's just like the end goal, or at least it seems to be. Just it's like the last thing. Like this, like you can't like call it or anything, but like the non-terminals, it seems like it could always like break down like into further stuff. Except for
I think essentially the way that I've always thought about it is that like non-terminals are essentially variables, whereas terminals are the actual like input that you're giving it.
Gotcha. I'm gonna write that down too. Yeah, I like that. Okay, cool. And then start simple. That makes sense. I think this is super important. I think like theory wise, he's probably going to ask you, he'll be like, what phase is regular expressions on or whatever.
Right. Yeah, I think that could be something.
Yeah. Do you guys have like a
multiple choice?
Yeah, for sure. There's also true or false, I heard.
Yeah.
Do you guys think like what would be your method for like memorizing all of it? I don't think the optional things are going to be important. But I totally think like he'll ask definitely about scanner and parser because that has to do with regular expressions,
Yeah.
context free.
I think the first three are absolutely going to be on there, the scanner, parser, and semantic analysis, just because he focused on that for a while in the beginning.
Yeah. And lexical analysis is just basically is it kind of like semantics, even though that's the third one, because you're breaking it up into tokens.
Yeah, I'd say kind of. It's
yeah.
essentially the beginning wherein you're describing what can be used in the language.
Yeah, okay.
And so if you try to use something that's not in the language, then it's going to give you an error.
Right. Like if you misspell int or something, then it's like, what is this? Okay. Gotcha. Would that be considered a lexical error, by the way? Like if you just misspell int? Okay.
I would assume so because I don't well,
I don't
yeah, that sounds right to me because I believe the computer would be essentially looking to see what data type that is, and it is like, this isn't the data type that was defined previously, so we can't use this.
Gotcha. Yeah, I think for mine I put like int a equals like f1 or something, and it's like f is not an int, so it would give you a lexical error. But I could also see how that's, I don't really know why I didn't get marked down for that because I feel like that could also be syntax, you know?
Right.
Whack. Anyway, syntax I totally got, because syntax is just like you got to use the semicolons, you got to, put the right looking stuff. Like my example was you did like 5.2. If you did 5.2, then it'd freak out because it's like that's not even a number.
I think essentially the way it is for syntax is everything that you have typed out is something in the language. It's just out of order or used incorrectly.
Gotcha. And that's why it's the stream, the token stream.
Right.
Gotcha. Okay. What would be your example?
Because you have all of the tokens being sent to the parser, and at that point, the parser is looking at it to see if those tokens in that order are a valid expression, essentially.
Yeah, that's fair. I get to totally see that, and then it determines whether that's syntactically right or not. And then what would be your example for like a lexical error? Like, would you put for your homework, for example?
Let me see.
Let me pull up my past somewhere too.
So for mine, I had just answered the, like having a symbol that isn't necessarily bound to anything, just like outside of a statement. Because I had just had a basic printf, and then after the semicolon, I just put a $sign because the compiler wouldn't, or the scanner wouldn't understand as to what that actually means.
The $sign?
Yeah.
Gotcha. Okay, cool. For those who are just joining, because I see some people are joining, hello. We're just doing kind of like a, spitballing of what we were going to go over all the homeworks and kind of talk about like what might be on the test or what the test is about. Everybody has the same stuff as host, so feel free to share your screen or do whatever. Yeah, let's have a good time and study, I guess. Yeah, I totally agree with you, Eric. That makes a lot more sense now, just using something that's not. But I still don't really see how that's different syntactically, because wouldn't that also be a syntax error? But I see that the token is not recognized, so therefore it's a lexical error in that case.
Well, I think essentially, I can't remember the exact breakdown of it, but I think it was more or less the fact that since it was after a statement, it's now expecting something else to open a statement, whether that's a function or like a declaration of a new variable or something like that. But just having a token doesn't allow it to understand how that would be a function, essentially, or how that would work in its just lexically.
Okay, for sure. Does anybody else have questions on homework 1? because we were talking about a little bit before some more people arrived. Nope, I'm gonna take that as a no. Okay.
And so he
Yeah.
had said basically that with the questions about the context-free grammar and stuff like that, there's not just like one answer, right? Like you can have essentially
Yeah.
infinite answers.
Yeah, it's very open to interpretation. I know a lot of people probably had different answers to, but if you look on Discord, and you scroll way back, obviously, people had different answers that still worked for context-free grammar. And I think you could do the same for regular expression, but usually you should be able to knock it down to only a few variables. If you have more, it can work, but why would you do that all that extra work?
Right.
Yeah. Let's see. So we talked about non-terminals and terminals. Talked about parse. Anybody want to go over the parse tree? Are we good on that?
Parse trees are basically just how you can break up each section, right?
Yeah, totally.
For the grammar.
Yeah,
okay.
like they were just, how I do it is I usually do the derivation on the bottom, which is just telling you what you're doing with B each time, or what you're doing, I guess. And
right.
Usually there's more up there, but and then I kind of go to the parse tree because just doing it like all at once is a little confusing. And it seems like the right side, I don't know if that's true, but it looks like the right side always breaks down. But if you go up one on the slides, which are in the chat, by the way, I lost it. Yeah, it's right here. They're going left. So I think you go either way.
I think that he never stated that one had to be specifically like in a given order. Like I think that one that had the B's from before was just in that order because it could essentially, because it was broken up into a 0 and then the non-terminal again. And so because of that, as you're just writing it, it just makes more sense to just write it going down the right. But like with regards to this one could be broken up however you wanted to.
Gotcha. Okay. That makes sense. Cool. Thank you, Eric. This stuff. Did anybody ever use their epsilon in a regular expression? I didn't use my epsilon. I used mine in a context-free, but not in a regular
In
expression.
context-free I did, but not in a regular.
Okay. Just wanted to confirm but it does, it's
just
under
because most of the time I don't think you really need it. Like it would have to be a really specific time of like having spaces in your strings that's like declared.
Yeah, and I feel like even if they wanted like nothing, then you could just enwrap the whole thing in a star, and you could have the user choose whether they want to input it once or not. But I don't know. There might be a good time to use it, so that's always good to know. Here's some more grammar stuff. If anybody wants to go over that, just chime in. Or you do whatever, honestly. All open to interpretation. Scanner and parser. Okay, this is kind of like, I guess, summarizing what we've been talking about for the past couple minutes. But seems like scanner for sure breaks up things into tokens, and that's the first, I think, phase.
Yeah.
Correct me if I'm wrong. Cool. First phase of the compiler, and that is going to do stuff and be like, oh, that's a token, no, that's not a token. And then the parser builds on that, and it just takes it all together. Does that sound good?
Yep.
Cool. Okay. All right. Scheme, my favorite.
The horror of parentheses.
Oh yeah, gotta love those parentheses, man. Okay, I see lambda expression, and I don't know if they went into this before. And it's on my notes, so I'm gonna go back, track real quick.
He had like touched on lambda, but like everything else that he used had used like cond.
Yeah, well, so like in the first slide, I think I skipped it actually, but in the first slide, he was talking about spectrum of languages, which I feel like might be a theory question. And he was talking about, there it is. imperative versus declarative. Did we talk about this? I don't even remember, to be honest with you.
I don't think so.
Okay, cool. So yeah, so imperative is like how should the computer do it, and then you could do it with objects, or you could do it with just like variables and gunk. And we're used to that because we're like C and C++ people, all of us, I think.
Yeah.
So we're totally down with that imperative stuff. And then declarative, this new one, which is kind of why we're having some issues. It's with the recursive, with the lambda calculus is kind of, isn't that recursive? Like recursively doing stuff.
Is that what lambda calculus refers to?
I believe so. I'm not 100% on that. Somebody else know? I'll take that as a name. Okay, cool. But yeah, definitely, I can 100% see a question on like, hey, what is? I don't think he'll be like, is C the imperative or declarative? But I think he'll be like, what is, is imperative this or is it this? And so I could totally see that as like a true or false or like a multiple choice, because like it or not, I think it's still part theory and part problem.
Right.
So yeah. But I mean, kind of looking at this, I mean, thinking in terms of, I don't know if we should go down into like the von Neumann and the object oriented, but I guess we could. I'm trying to like think of like what, like acronym or something that would help everybody. But honestly, I just think the best thing is just to remember it, flashcards or something. And Prolog is scheme, is it not? Or as Prolog, Lisp is scheme. Yeah, it
Lisp
says
is
scheme right there.
yeah.
Yeah, scheme is scheme. Never mind. I'm silly.
I think scheme was built off of Lisp, if I remember correctly.
Yeah, that sounds right. That sounds totally right. I could see that for sure. Because I looked up Lisp on like Yahoo one time, and it looked pretty similar. I don't even know why I was on Yahoo. Anyway, lambda calculus, I think recursion. Aaron's checking that out, or Eric, excuse me, is checking that out. And then
I think it's just more so about how it's declaring functions, because everything that I'm seeing is that it's talking about like using variables with binding and abstraction.
Binding and abstraction.
So I don't know if in that one homework assignment for coding, if you ever attempted to use like lambda while defining a function.
No, I didn't.
It had like its own thing. I gave it like one shot and then gave up and just did the rest like everything else.
I think I remember exactly this thing, right?
It's like that.
Okay. Got it. And binding a name to a function. Got it. Okay. So that's lambda. Okay. Anyway, I think that totally helps me understand that better. So thank you, Eric, for bringing that up. But I totally think declarative and imperative, 100%, how the computer should do it, and then imperative is like C, C++, object oriented, which we're used to that kind of stuff. And then declarative, a little wonky, but like what the computer should be doing. Or like
I think that it could be worth also just kind of like knowing which language kind of falls under what. Like I don't think that he'll ask us about the ones that he just hasn't said anything about, like small talk.
Yeah.
But like I think knowing where C, C++, and scheme at the very least fall under, I think that's probably a decent chance of showing up as a multiple choice question.
Oh yeah, that's totally fair. I think for me, C++ is just like that hammer. I've been hammered in, to know that's object oriented. The von Neumann thing is a little odd, but it makes sense. I mean, we're just messing up with int x or whatever to change stuff.
I think he had said that, and correct me if I'm wrong, but that C could kind of fall under both. I thought I remembered him saying that like it could like not imperative and declarative. I'm talking von Neumann and object oriented. I can't remember if that's what he was talking about, because this first lecture was way back.
Yeah, I think if he does ask a question and he's like, "What is C?" then just go with the von Neumann.
Yeah, I think it's safest bet for that.
Yeah, but I could totally see, because you could basically, I don't know, that might be blasphemy to say you can make stuff in C which is the same as C++, but
Right.
I wouldn't imagine it's too different, but I don't know. Anyway, imperative. How should the computer do it? Declarative. What should the computer do? Object-oriented and modification of variables. Super important for imperative. And then how should the computer, or what should the computer do? I have to keep like reading that to myself. Yeah, and then we'll do the functional is what we're working with right now because that's scheme. And that makes sense because lambda calculus and we're using lambda for functions, although I just used define. I don't think we get dodge points or anything for that. And then logic, specify constraints and relationships and find values to satisfy them. Sure. Sure. That just reminds me of CS365, but I know not everybody has taken that yet, or some people have taken that like last semester or something. So I don't know. To me, that sounds like you probably won't go into that much because we haven't even really covered that too much.
Ooh, that I was about to say is probably going to be pretty important.
Okay. Yeah, that's all on red. That's usually not a good sign. Atoms are lists. Okay, atoms just like single. I want to say variables, but that doesn't sound right. It looks like it's a single thing. Like
essentially, it's the thing that you're assigning. It's generally the thing that you're assigning to a variable. I'm pretty sure.
Gotcha.
Is an
and then
easy way to think about it.
The list is a sequence of those things, which makes sense. I guess that makes sense because you did like parentheses of like 1, 2, 3, and then end parentheses. Like that's a list, right?
Right. Yeah.
Gotcha. Okay. So then, what a single string does that count? Like if we're going back here. Whoops, not there, not there either. Here we go. Like square, for example. Do you think it's a string or a atom or a list? I would say it's an atom.
Yeah, it's an atom. I think just in general, with especially by defining scheme, it's not in and of itself within parentheses.
Gotcha.
So like that's an easy way to tell that it's not a list.
Okay, so like this whole thing's a list. That's atom. This whole thing's a list, and then those two guys are atoms. So that's so on.
I think so. I think that's a good way of looking at it.
Gotcha. Okay. Okay. Cool. Excuse me. Constant atoms evaluate to themselves. That makes sense. You type in 1, it'll probably be 1. Identifiers and symbols evaluate to the value bound to them.
So is that just essentially meaning like variables in that case? Like is identifier the symbol being used to hold that value, I guess?
I would think of it as define, like define a 5 or whatever. Like I don't know if you could see this.
Yeah, that makes sense.
Like define A is 4 or whatever, where you put A. Like
Right.
I think that is what that's looking for, basically.
Okay, that makes sense.
Yeah. And homework 2 is honestly, I think that was one of the hardest ones.
Homework 2 was the programming one, right?
Yeah, homework 2 was the programming one. I did okay.
Yeah, I'd say that was the one that took the longest.
Yeah, I started super early, so I got super lucky. But that thing was a pain in the butt. But first time learning languages is always like that. Preventing evaluation, use the quote. Yeah. Forcing evaluation, use eval. So that makes sense, right? Because we have the.
So was quote the keyword essentially to use it to treat it as like it's a string?
Yeah. So I think it's like this, like quote, or we probably have to close it. This is 1, 2, 3. Then it's like that. Do you see scheme by the way?
Yeah. Yeah.
Okay, cool. And then like if you just do 1, 2, 3, I think it'll be 123. No, it won't even do anything. Okay. And that's the same I think as if you do this. Yeah. So this is.
Gotcha.
Equal,
okay.
Yeah, that equals this. If I can type correctly.
All right, that makes sense.
Yeah, for sure. Yeah, I think you would have to do like, I guess a better example is like this. And then you could do like that. Yeah. So that makes sense to me, like breaking that down. Anyway.
When would you want to be forcing an evaluation?
That's a good question. I have no idea. Can anyone think of any like examples of like when we would even do that? Or like they could pull up their scheme or something.
Wouldn't wouldn't it automatically evaluate when you put the expression in there?
I think unless you use the quote operator, because like we did like this, and then we did like this. All right, like there. Well, oh my goodness, that's why I'm a CS major, not an English major. Okay, cool. So it does like that, and then this one it's like forcing the evaluation. So Eric was like wondering like when we'd even want to, like why would we even ever want to force? You were asking why we want to force it, right?
Yeah,
Your
because
question?
the eval keyword is used to force an evaluation, but I don't see exactly when we would need to outright force it if it just most of the time does it. So I'm trying to find an area where that keyword would apply.
If we look at the old, I have my homework on me, which we'll just pull that up real quick. I did good on the homework, and hopefully it's clear. I tried to be like as detailed as possible because I wanted to make sure that I knew what I was doing. But like, I think in like terms of these, I don't know if technically that counts because obviously, so like if this is the first question by the way where we're replacing stuff. We use the quote, and that won't do anything. But that's kind of list stuff, and I don't know. That's not really evaluating. Like when I think of evaluating, I think of numbers. So it might be better to do the second one. But usually you're messing with the list. You know, you're determining whether it's true or false or stuff like that. So honestly, I don't even think we did something that forces the evaluation. Maybe here, maybe like when we're counting nodes, because this +1. Oh yeah, this is a good example. Okay, so like this one, I would say we want to use the evaluation. We're basically counting all the way down. Each time we call this, we're forcing an evaluation of +1. And so every time we see a node on the left or the right, we're counting it. So I would say that's a good time to force an evaluation for like either counting or for like factorial. Factorial is a great time to force evaluation. Dang it, I would pull up homework 4, but that's not due yet. If this was tomorrow, I would pull it up. Anyway, but yeah, factorial kind of stuff are like what was that thing you did? GDC. GDC is a great time to use force evaluation. But list stuff, like if it's like, you know, what's the or like this one. Honestly, anything where you need to count. But like if it's like what, you know, are these the same or like do it post order, I don't think append or any of that is like forcing evaluation. But that's a little I think that's a little too nitty gritty for what
I don't think he'll ever need us to use it. I just wanted to know if anybody had any good insights for it. But yeah, that makes sense.
Gotcha. Sorry if that was too in detail.
No, not at all.
Cool. Anyone feel free to stop me if I ever go like too much, being like, hey, we gotta move on to some other stuff, because like I said, we're all kind of the teachers here. So binding, that's how you bind stuff. I use define, way easier.
Yeah.
I don't think it'll matter on the exam. Recursion, like I said, homework 2 was kind of the toughest one for me. Does anyone want to go over some homework 2 questions that they were like, what does this do? Or, you know, I had trouble with this one, and we could kind of go over it together. Like, you know, I have my notes, and if that one doesn't help you, then I'm sure other people have their notes that they could screen share and, you know, pull up their specific method of doing stuff.
Let me take a look at the homework.
Gotcha.
I added the link. I was just curious about the eval, but there's a section for eval where it discusses exactly what it does, but it seems like it's just the best way I could describe it is it's doing the opposite of quote. So if you combine the two, it'll end up just not doing something.
Like the keyword eval, like this?
Mm-hmm. Yeah.
Gotcha. And if you do like what would be an example that you would say? I'll just like throw it in here.
So
I see it.
if you do like quote next to it, like the
quote here.
Yeah.
Well, you'll need another parenthesis though.
Oh,
I wasn't
before
sure
the
if there's
quote.
another
Sorry.
one. Yeah.
Might be. Okay. And then
Like the +1, 2.
gotcha. Oh,
Yeah.
very cool. Okay. I had no idea about that. Thank you, whoever brought that up.
Yeah.
I actually don't know who brought that up. I want to say Dwight. Thank you, Dwight.
That's me. Yeah.
Okay. Thank you, Dwight. You rock.
Thank you.
Yeah, that makes a lot more sense actually.
Yeah, that makes a ton more sense. Awesome, guys. Super cool. Okay. Super duper cool. I had a question on, I was going back on some of my notes, and I had a question on, I gotta find it because I started somewhere in here. It had to do with, so nuisance on this paper. Oh yeah, cons versus a pen. Because I think cons takes like the first head and connects it to the second, or like the first.
I think
yeah.
con takes a head, which is a single, like its own thing, and then tacks onto the rest of it a list as its tail, and then append just merges two lists. Is that correct?
I am not sure. We'll see. That looks.
That sounds right to me. I'm looking at my code from homework 2, and I use cons and append in this one function.
Can you share your screen if possible, if you're comfortable with that?
Yeah, I'm good with that. Let's see. So, screen 1. All right, can you see this?
Yeah, we can see it.
Let me get up scheme as well. So we can use it. So for flatten, if I remember correctly on the homework, flatten is it took what did it do?
I think it removes all the parentheses. So like if you have like like 1 and then parentheses like 3, 4 and then end parentheses and then 4 end parentheses, like if it's embedded, then it removes all of that. It just is 1, 2, 3, 4. I think.
So it takes in a list. I mean we could probably test it actually. Flatten and it takes in a list, so
Yeah, that function was that it took in a list along with lists inside of it.
So right.
And then it would break it down into just a single list.
Right. Yeah, that makes a lot more sense. So it would take something like 1, 2, 3, 4, like that.
Yeah.
Right.
I think it has to be quoted too.
Yeah.
Does it need to be quoted?
I think so, because those are like numbers.
Oh yeah, it's trying to like you're right.
Yeah.
It's trying to
I think you just need one at the very
Yeah, I think you just need 1 in the end.
Oh my god, what am I doing?
It's all good. It's all
what
good.
happens when you use this thing.
Yeah, scheme is scary.
Yeah, I think you're right. We probably only do need the 1. Okay, never mind. And hopefully this one.
Yeah, that one. I think you have to hold the end.
I think that's
Yeah, there we go.
Yeah.
Okay.
Yeah.
Okay, great. So now that we figured out what it actually does, so it uses cons here, and it has the head, and then the flatten, and so flatten will return a list. So this is a list, this is a head. So what you were saying makes sense. And then append, we have 2 flatten calls, so it'd be 2 lists, and that's merging them.
Right.
So I think you are correct that it takes 2 lists for append, and cons takes a head and a list.
Gotcha. Thank you, Andrew? Question mark.
Yes.
Andrew.
So
Thank you, Andrew.
I think that should be good then. Yeah.
Can append take more than 2 lists? Like, can it take 3 or 4 and keep appending? Or is it just flat out 2?
I don't know.
Sure.
I think it only takes 2.
Okay.
I mean, you could just append and then append.
Right.
So, or recursively append, I guess would be the thing.
Gotcha. Let me check actually, since I just have it pulled up right here. You said append and doing 2 lists, or 3, I guess.
Oh no, I think you can do it with more than. I think it just needs
Yeah, you
multiple
can.
lists.
You can. You totally can.
I apologize for the false information.
Oh, you're good. You're good, dude. We're all learning together. It's fine. I'm gonna say some wrong stuff eventually. I probably have, to be honest with you. Anyway, can you guys see the PowerPoint again?
Yeah.
All right. And does anybody have like any questions? Yeah.
I do. You said the PowerPoint was in the chat, but
Yeah, it's the
people
first
who
one.
joined later can't see that early. So can
Oh, dude. Yeah, super sorry. Super sorry.
It is also lecture 12 if you're on Canvas already.
Yeah, lecture 12. And I
which
will
should be
throw
the
it in.
latest one.
Okay. Did you get it now?
Yeah, I did. Thanks.
Yep.
Okay, cool. Yeah, and feel free to follow along. It starts on, and just like for your own study time too, it starts on 29 and goes all the way down to 70. And so what I did the other day was I just took like a ton of notes and just kind of hammered it out.
Has he said if we're allowed like note pages or anything like that?
I 100% doubt that we're allowed notes because he's doing Proctorio, and Proctorio
Right.
is not a kind mistress. But yeah, I don't think so. Be nice if it did though. Be super nice. Does anybody think that we're going to be using like these tricky ones, like local definite? Honestly, I don't remember. I remember apply does like, I think it's like, does it for each element in the list, but that's about all I remember.
I don't think he had us use these like at all.
No, not in the homework.
Like we went over a couple things for display. That was pretty much it.
Yeah, I don't know if we'll go over those, but it might be good to check out what they do. Or like,
Yeah, I don't think I used any of these.
Yeah, neither.
I don't think he had gone over any of these by the time that our coding homework came out. So
Gotcha. Do you think he'll throw? I mean, he threw it in the midterm study guide. Well, if this
He
is
might.
considered a study guide.
Wait, is there a study guide?
I mean, this is it. Like just the PowerPoint. That's all we got.
Oh,
Yeah.
I see.
It's I don't know. I think he might do something like that. I don't think he'll do read or display. He might do display.
I think display might show up, but I mean that's simple. That's just it's literally just printing the thing.
Yeah. I think. It's just like this, right? No, it's not. It's like, whoops.
Well, it's just because
I think quote X.
Yeah.
Okay.
Yeah.
So like within a function, you could just have that in there, and it'll print it out as it goes.
But wouldn't just like doing quote X normally also just output X?
Yeah, I agree. Like, why would we use display? Like, what if we did? No, because that's really the same thing. Yeah, I don't know.
I'm just thinking of it through like kind of like the coding homework that we did, where deep into the function you have it display. So like not at the end, because this is essentially just doing the quote, but I don't think, because quote doesn't actually like print, right? Like if that's the return, then it'll print. But I don't think quote will ever actually just print it out, right?
I don't know on that either. I think it will print it out once it sees display. Like it'll just like.
Well, yeah,
throw
it'll do it once the display like if you're tacking on display to it. But if you're like within a function and you just use quote, I don't think that'll print it out the same way that display does.
That's fair. And then also I noticed it takes away the quotes, so I don't know if that even matters, but that's pretty interesting.
Huh.
Yeah.
Weird.
But like I don't think that'll be a big thing. I doubt local definitions. If you guys want to go over that, I think we should go over that later because I mean there's still kind of a lot to hammer out, and I know you guys want to enjoy your Monday or whatever day it is. I hope it's Monday.
Yeah, it's Monday.
Feels
Gotcha.
like it's already like Wednesday.
Yeah, it really does. It really does. That scares me. Anyway, I'm glad we're going over this now instead of later. And hopefully maybe we could do another review session, if you guys are ever down, and that'll be way more, detailed. We're just kind of doing a impromptu kind of thing right now. This makes sense to me that atoms are just kind of like a pointer to a thing, and then the list is kind of like a node list, if you want to think of it that way.
Right.
I kind of went over that
And
thing.
an atom in this case would be X or 1. Is define an atom or not?
Define as an atom, yes. So define as an atom, X is an atom, 1 is an atom, but this whole thing here is a list.
Okay.
I think the better breakdown of it is that define
it's
is
in
considered an
parentheses.
expression.
Okay.
Because expressions can be atoms or lists. So like technically calling it an atom is fine. I think it's just generally thought of as an expression, just to differentiate it from actually being something as small as X or 1.
Gotcha. Okay. Yeah. Did it say that in the? I totally agree.
It said
with
it
you.
like way back up there that because it was just stating that expressions are atoms or lists.
So
I'm gonna take your word on that. I'm not
in
gonna
a
go-
for functions, you can have a list as a parameter, like we used capital L.
Mhm.
So in the function definition, is L a atom or is it a list?
I think it could be. Well, technically,
I
it's
think it
whatever you
depends
want.
on where you're looking at it from. Because L is a list, no matter how you're looking at it. But if you're looking at it based off of what you're putting into the function, I think L would be considered an atom.
Yeah, I totally agree. It could be whatever. Well,
It's
I'm
an
gonna
atom for the
just do it.
function, but that atom is a list. I don't know.
Yes.
It's kind of weird.
I agree with. Oh, sorry guys. I agree with Eric 100% because, like in the homework, like the first homework, we defined L, but then we passed in a list. So I could see where you think it's a list, but then
I don't think
technically
that
you
would
could
ever
also
be a
throw in
question. But
Yeah,
if
I
it
don't
was,
think so.
I would still just put down list, just because it is a list. I
If
think
they said what is L,
yeah, I think if they were essentially saying like what is L and the answers were like list or atom or so on, then I think it's easier to say list because it is a list.
gotcha. Okay, cool. Binding. Oh yes. Okay. Yeah. Let me actually flip back to my notes. If anybody wants to say anything on binding that they think will be helpful, feel free to chime in.
Oh yeah, the binding homework.
Yeah, binding. That one was tricky. I feel like homework 2 is still a little more tough, but binding
Homework
made
2
me
was
think
more
about-
time consuming, but
Yeah.
at least like you could check your work very easily. Like it took me like 5 hours, but I did it in one sitting and it wasn't too bad.
Yeah,
I
as
just
long
had
as you
to
get checked.
keep trying shit stuff. Yeah.
Yeah, I feel you. But then with the binding, you're like, did I do this right?
Because I did end up getting like 5 points off.
Yeah, I missed 2 points. I got a 98 on that one because I missed static. And if you guys want to go over the homework, like I know probably everybody's gone over their respective pieces, but we could just go over that and do a quick rough draft or overview if you guys want.
Yeah, there's the kinds of binding. There's static and dynamic binding, and dynamic binding has the 2 different kinds as well. What was it?
I think it was the deep and shallow.
Yeah, deep and shallow binding, right?
Yeah, okay, deep and shallow for sure. That's actually like a little bit down here. I'll just scroll to it because
There it is.
so yeah. Use the environment from the moment when the function is passed, stored, or returned. And then shallow is use the environment from the moment of function call. So function call is like you're actually like that's the name of the function you're calling it. But then passed, I think, is the one right before it. So like let's say, why do we have these examples? Why not just pull up homework 3? Let's say, no, that's lab 3. Give me one second. If someone also has their homework 3, feel free to share. But I'm gonna try to find mine real quick. No. Let's see. There it is. Okay, homework 3. This guy, right? Last question, wasn't it?
Yeah, it was question 4 that's
Yeah.
using the deep and shallow.
So like the call here is actually, if you look here, it's the actual P, close parenthesis, that's the call. And then so
Right.
anything in that environment, the x =2 is following that. And then the pass is going to take that y equals 3 environment, because the pass is going into that, which is going to do the call. Pass, I think, is always before call. I don't know if that's 100% true. What do you guys think about that? I mean, I think it's always before call.
I think in most cases,
Yeah.
I wouldn't really see a case where you'd be calling the function without having passed it already.
Yeah. So then, like, for static scoping, static, how I think of it is you just always take the higher thing. So, like, for example, like when we go to add, we're not really looking at like what calls what, but we're just like looking at like what happens from top to bottom. So you see the first two like assignments, and then you see procedure add, and you don't worry about like what's calling that. You just go into it and you say, okay, x equals 1 plus 2, and then you move on with your life. And but at least that's how I did it. I'm not sure if, or you could say like they always refer to the top. But
Right.
What did you guys? How did you guys kind of go about that? Because I could totally be wrong and just kind of got lucky. But
I had basically the same idea. Is that static scoping generally refers to the top level environment. So it'll look at the global variables and use those rather than using the locals.
Gotcha. So
or any
here
shifts.
it is just a local, right? So if that didn't say integer, my question is like if it said like x dot dot equals 2, would that change the global to 2?
If it was what?
If it was not a local variable, so if it just said x equals 2 at that point instead of integer x equals 2 making it local, if it just said x equals 2, would that change the global variable to 2?
I'm not sure. I want to say it would, but I don't know.
Gotcha. Only because
this is pseudocode, I don't really know how he wanted it to look exactly.
That's fair. I was thinking that these were already, the other two were already. I don't know if you guys can even see that now, so I don't even know why I'm doing this, but I'll do it anyway. Maybe can you see my mouse, by the way?
Mm-hmm. Yeah.
Are you good? Oh, cool. So yeah, I was thinking that these two were just local, so I didn't even really think about them like messing with the global thing. But I think that if it was like x dot equals,
I want to say that he did probably mean for it to be changing the static variable, or like the global variable. I mean.
Okay. I might
because it's on a static call, I don't think that it really can. So I think that's why the first answer is 3, is because even though it's trying to change it, it always refers to the original global declaration.
Okay. Even if it was manipulating it, it would always just be the top anyway.
I think so.
Okay. Gotcha. And then, sorry, we completely avoided Blake's question. So for shallow, we want to do the call, I believe. And the call is here when the actual function is called. So we're taking x equals 2. And then I assume.
And y equals 3.
And y equals 3. Thank you. And and then we're getting 5. And then we're passing that back. And that's not what we get. We get 1. We get 1. Actually. And I gotta actually read up on why that is, but I forgot to.
Right.
Because the answer is for
that
sure.
Too.
So it says x equals 2 for sure, and then it's still in effect using blah blah blah. But I would assume the global variable is still in effect for the. There is also no one check. Local variables are in effect. Oh yes, Jacob helped me with this one. Jacob is a very cool dude on Discord. He is always helping me out. So Jacob was saying that even for shallow binding, you do take the element that's in there. So we don't take the y equals. We do take the y equals 3.
Oh, I see it. Right.
Yeah, and then it's local anyway. And so then even in procedure add, it doesn't matter what procedure add does. And I honestly, I don't even know what it still does, but it does stuff to certain variables that I don't really know. I think x is 2 and y I want to say is still the global question mark, because
I think the way that I want to say, and tell me if I'm wrong, but I think what's happening is when you call first, you're going into the first, you're setting the y variable, which was 2, 3. Then you're going into second, which sets the x variable to 2. So now you're looking at 2 and 3. And then when you call P, you're going into add, which creates 5. But once you leave, because that's done with first, your X is still a local variable at that point. So when the function call to first ends and you get to write integer, that X, the only thing that you have there is now the global variable.
I totally agree on the leaving, and then that's the global variable 100%. But I'm not sure if Y is set to 3. I know for sure X is set to 2, but I don't know because I think shallow just says, let me see, uses the environment from the moment of function call. I mean, I don't think, but technically call is in the environment of pass, so I don't know. What do you guys think about that? Or I could look it up maybe.
Because I want to say that if there was an actual print function right after the like x equals x plus y that prints out x, then I think that it would be printing out 5. Because I want to say that with the way that it's nested, with second being inside of first and second being the one that calls add, I want to say that call at the time of that call, y has already been changed and so has x. And so I think it would print out 5 if it had a print function inside of the add. But I could be wrong. It could only be looking at the stuff that is inside the like newest loop.
Well, let's
like
see.
Inside of the loop of the call.
Yeah, let's see what these people say. So like shallow, if we're doing shallow in this case, it looks like here's the main, and then we're going into, obviously we're going to add, and it looks like we're going to return the add. So very, very similar to the homework. So we're going into foo, we're doing some stuff with integers, and then you're saying that v will be whatever element is in x right now, which is going to be u.
I think so.
Okay, because this is the call for sure, because this is passing
Right.
an add, and then this is the actual call of that function. So if, let me draw on this. So this is call, because it's actually, nice, I chose white. That's a nice color. Okay, so this is the call, because it's passing in the add. And I totally think that this will, I'm going into detail on this, because I think this is going to be amazing for sure. And then this is the pass. And so Eric is saying, hey, this v is going to be x, which is going to be u. So basically 42 is v. So we got that. And then we're passing in whatever. So then u is w. Okay, so w, so that's 17.
Which is
Yes.
that? Is that considered? Yeah, that would be the actual w, right? Not the 13 that we had sent in previously. I'm just asking because that's counted as w inside of foo.
Mm-hmm. I don't know. We'll find out in a minute. But it could be or. We'll say or 13. We'll find that out in a minute. So that
it would
means
still go 17, but yeah.
you think, okay, so we think this. And then z, which is going to be our final thing.
I suppose it doesn't matter in that case.
Yeah, what is z? Where is z? What is z? Oh, z is
Z is the given one.
I wasn't looking. Yeah. So z is v, right?
I think so, yeah. So
Okay.
I think it would be, so
72.
yeah, so that would be 42 if
42.
by my
Yeah.
process.
Gotcha. So that means that the answer would be, we're going to calculate out. So this would be
42 plus 17 plus 42.
17 plus 42. 101. Or if we're going with that other, if we're going with the 13, that would be what, 13 plus 42
97?
plus 42. I got 8. Oh. Yeah, you're right, 97. Okay, so is it 101 or 97? Let's see. And I'll just clear this up.
Dynamic scope shell binding answers
That's just
69.
his wrong answers. He's not
Oh,
sure.
okay, gotcha.
The answer's down here. Okay, so static scope, he says correct.
Static scope.
He says the answer is 1. Oh, wait, that's
26.
deep binding. That's deep binding.
Oh, okay, gotcha.
It is 101. It is 101.
42 plus 13 plus 4. 42.
Yay, 101. Okay.
Wait, isn't that what he had
wait.
asked? The
No.
correct answer he said was
Oh, dang.
97.
It's 97. 97. Yay. Okay. So that
Definition
means
bar. Yeah, right. So inside of one of those original or one of the inside functions, it's declaring W, like it's making W its own
This guy.
thing at this point, right? So
This
inside
guy.
of foo, it's taking W as its own thing. So it's no longer looking at the global one.
okay. So in this, back to our example then. In this case, y is 3, like you said, and x is 2. And then it's doing 5, and then it's leaving that, and it's going, hey, write integer x. Well, we left it, so it doesn't matter. So now it's just 1 again.
Right.
Is that what you're saying? Oh, okay.
Yeah.
Cool. Do you guys think it'd be helpful to go over another one of these, like with static and with deep binding, since the answers there? Or do you think we should just move on? It's up to you guys.
I think it's worth looking at deep binding again because I can't remember exactly why it was so different.
Okay. So for
Like, I don't remember why augmenting it would actually be different.
Like changing it. So like in this guy, I think it was 3, and then we ignored what x was changing to because we just care
Right.
about the pass environment. And then x would be the global, which is 1, and then plus the y, which is 3, and so 4. And then blammo.
Why does that not die again? Is what I'm asking, because they're both dynamic scoping. So what is it about shallow binding that causes that to drop out, but deep binding keeps it? So like something about deep binding is allowing it to change the global variable.
No, I get you. Yeah, yeah, and then it's keeping it. I don't know. What do you guys think?
The only thing that I could assume is that just with deep binding is that it allows you to actually, from a local scope, change a global variable. Whereas with shallow, it's not.
I mean, I would say so, but I don't know. Maybe the guy said that. Maybe.
Yeah, maybe go to his explanation about deep binding.
Yeah, for sure. Dynamic. Blah, blah, blah. Shallow binding, deep binding. No, he just says the answer. That's kind of funny. Here we go. If this has deep binding, is much thicker, since few widely developed blah blah. No, it doesn't have anything good in it. If anybody finds something on dynamic deep binding, because we totally get like when it's manipulating stuff, like what elements and environment it takes, we just don't understand why it why it changes the global variable of x, unlike shallow binding. That's kind of our main confusion. So like here, I think, like for example, like this is pass. So like v is x in this case, and x is u. So then therefore we have 42, and then we pass that in, and then this doesn't matter in deep binding because we're only caring about this environment, I think. And so that means that this v is actually the u because that's what happened here. And the u is still the u, even though this happened here, it's ignored because deep binding only cares about the passing environment. And then z is v, which was already changed here. So I would say that's just whatever this is times 3. And 126, we're going to scroll down. And he says, for shallow binding, it says deep binding, excuse me. Deep binding. Oh my goodness. For deep binding, it is 126. So that's true because we did u plus u plus u. So I totally get like what's good. I think me and Eric totally get what's going on here, but we just don't understand why it's manipulating the global variable here in deep binding.
I think I see it now.
Yeah.
So with shallow binding, we've established that we've created a local variable, like we've created a local variable essentially of y and x when like back to the homework problem.
Oh yeah, absolutely.
So we've created like the local variables for x and y that'll be passed into add, and then that'll make the sum there. But when we're doing deep binding is called at the pass, right?
Yes, deep binding is called pass.
Right. So we've
stuff.
established a local y, but the only thing that we have for x at the time of add is our global variable. And so because we don't have a local variable established, because I think now that I'm looking at it, the x integer and y integer are completely local variables. They're not augmenting the higher variable at all, just from the fact that in procedure add, the original x isn't creating a new x. Like it's not saying x integer equals x plus y. But anyways, that was off topic.
Right here.
Right.
What you're saying? Okay. Yep.
But that was kind of off topic. But back to the deep binding. We have a local y, but the only thing that we have for x is our global x. And so when we're putting that into the x plus y, it's easy to know that it's 1 plus 3. But the only x that we have to change is our global x. So the sum is being written back out because that's the only x that we have defined at this stage.
For deep binding.
That's why it's able to change it.
So you're saying for deep binding, since it's declaring the global here and it has no local to change because no local was declared here, then it can only change the global. Oh, okay.
I think if we had put the like x integer equals 2 inside of first, we would end up with the same thing as the shallow binding, wherein it's just being, or like the same thing that we have the shallow binding with this example, wherein it's just it's giving out 1 because at the time we have 2 local variables, and then we're changing the local x, and then it would be bumping back out. I think
that makes sense to me. That makes sense to me because the local is ignored in this case with deep binding because it only cares about what's going on in past, so it doesn't even know. The only x it has is the global. So right. I totally agree with you. That's once again, I really wish the professor was like here in like spirit form or something, or like I guess somebody could take all his notes or something, or ask him. Tomorrow I'm sure we'll do like a review thing for Tuesday.
Right.
But this definitely helps to get our questions up front. Yeah, I totally agree. And then I was looking back at the other thing. I can actually click mouse. Oh my goodness. Gotta love Zoom. Okay. Shallow still changes u. And so, like, for example, like we do stuff in this function and we leave it, but we're still using the u that we calculated in this, which I believe was 101. Oh, excuse me. So
97, I think, was what we had calculated.
97, excuse me. It was 97, yes. Let me check to make sure because I don't want to give false information. Yeah, 97, yes, because we did the 42, we took in yes. So in that case, what's going on there, do you think? Like, why is that one returning the u in shallow when the shallow in the other one did not do that?
So so we're looking at shallow binding, and then it was
the call.
Right, which is the call, and then it was printing out 97.
Yeah, I was printing out 97. So I was printing whatever the sum of this was. So this was still leaving whatever, and then it was still using the u that we just calculated in add. Sorry if I'm not making sense.
No, that makes sense. I'm just trying to give it a look through.
Yeah, I'm trying to think about it too because now I'm like understanding the logic of the homework now, which everyone's on the same page with the homework. That's cool. And if not, just chime in once again. We could go over that real quick because we might have.
Could you link that in the chat really quick?
Yeah, of course. Sorry about
I'm
that,
gonna
guys.
give this a closer look.
Should have done that at the start.
Let's see.
Yeah, so there's that for you. But yeah, I am not 100% on because I definitely know what environments are being called, but I'm not sure about the final, like why we return the sum here and why we don't return the sum in the homework problem.
Oh no, we are right.
Right in the
It's not outputting. The print U isn't outputting 97. He's saying that the sum becomes 97, but because that's a local variable, it dies off and it is printed out as 42.
Oh, did I not read it all the way? Oh man, I'm sorry, guys. I did not mean to give you guys. Oh, yeah.
No,
yep,
because I thought the same thing back when we had solved it. I was like, oh, it's 97.
Yep, the answer is 42. Okay, got it. So it always just dies. Got it.
So
Sorry, guys.
So it is leaving its function call. The local variables all die off, and then you're just left with the globals.
Always for shallow. Okay, gotcha. My bad, everybody. that cut a few minutes into our session. Sorry about that.
No worries.
Always good to know, though. Thank you, Eric, for pointing that out. I totally would have had some trouble with that, so thank you. I appreciate that for sure. And then for static, we're just using the top. So aren't we just using the 42 as well? No, maybe. I don't know. Maybe we're doing this.
Taking the sum of 42, 69, and 17.
Yes. Okay. And 17.
Maybe not.
Well, I don't know why 17.
Or no, not 17.
Would it be B again?
I think so, yeah.
What even is Z in there for static? Because it's always talking about the top. You know what I mean?
Right.
So that's a little whack. Why stare at it when we could just look at what's going on? He says 180.
Gets sent, right, because Z is what gets sent in, and that what gets sent in is V. So it's 42 plus 69 plus 69, which is 180.
42, which is, excuse me, plus 69. And then this is 69 because it's here.
Right.
Okay. And that is the top stuff. And so we're ignoring this U equals W?
Yeah, because that int U and int V, the two that are below, both of those are local variables, so we don't even care.
Gotcha. So when we refer to V, we're always referring to these guys.
With static, yeah.
Okay. Got it. Super cool. And then U, I assume we just use this U because this is technically manipulating the global variable? I
believe so, yeah.
Gotcha. Okay. That makes sense because this is local. Cool. Very cool. Okay. Let's move on from that one. Does anybody have any other questions for homework number 3? I feel like we're getting to the end. we're getting to homework 4, which we probably can't go over until it's released. Just because I don't know. I feel I'm a little skeptical about the school system.
Yeah, no, I think it's best if we hold off on that. We can go over it again before the test later.
Yeah, I totally agree with that. But homework 3 is, this is the last homework we're doing for today. So if anyone has any questions on the one I got wrong was this guy. This one. I had
C wrong on the second question.
I had A wrong on the whatever question this one was. 3, but then that was it. So I got a 98. And you got which one? C?
I think it was C. Let me check.
I don't think there's a C for number
2. It was whatever one had the number 3. My bad.
Number 3. Gotcha. I got number 3. That one was tricky.
Number 3 was weird.
Yeah, number 3 was super weird. But I totally understand. I went to the professor's office hours actually after I got this one wrong, and I was like, "Hey, can you help me on this? Because I'm a little confused. Need some guidance, So we could go over that one if you guys want to. And
if nobody has any objections, then sure.
Yeah. What do you guys think? Or if there's another homework problem you guys want to go over that's even in the past or whatever, always down to mess with that. All right, I'm gonna take that as a yes. So for the first one, I believe, oh man, yeah, I had to go into the book and I wrote down this stuff. Sorry, it's kind of like a big mess. But so in the first question, it says names must be declared before use. Got it. And the scope of a name extends from its declaration through the end of the block. So we're talking about the inner, the middle, and then the outer. So
Right.
for the first one, I'm going to do a side by side because I think it will help a lot better if I can. There we go. And then I'll just pull up a copy of this just to save time because I know everybody's probably getting tired. That is a blank document. That does not help. Oh no! No! I deleted that on accident. Sorry guys. Hang on. Give me 1 sec. Goodness gracious. Okay. Got it. Perfect. I hope. We'll just do another one. And do it really fast. There we go. Go here. Zoom in. Why is that blank again? Come on. Oh, jeez. Okay, if it's blank again, then yeah, whatever. So, you know what? Sorry guys, once again. My bad. Here's what I'll do. I'll copy and paste this here, and then we'll just go from there. Does that work for everyone? Can everyone see that?
that works.
Okay, cool. So for the first one, it says names must be declared before use, and the scope of the name extends through the block. So for the first guy, I'll zoom this up, of course. So for the first guy, we're talking about the very inner, which is right here, which is the print AB on line 7. And so we know we have to use any declarations before this, even though it's called here's what I messed up. So I put what did I put first? I put 1-3. I put 1-3 because I thought, hey, it's called on line 10. So originally I had my line over 10, but it's calling that, and so it's using line 8, a equals 3. And so I was like, oh, okay, so then obviously it's going to be 3, 1. But the professor said, no, you can't focus on the call. You have to focus on where that function is actually taking place. So you got to use 7, and then you go up, and then b equals a, okay, and then you go up from there, and you go, okay, so b equals 1, and then 1. So that's what I did for the first one. And the second one, the middle block, which is on line 11, that one is going all the way up, and a is equal to 3, and b equals a. This b equals a is actually using the global because we can only declare before use. So therefore b equals 1, which is the global a, and a equals 3, and so there we have 3, 1. Moving down to the very last one, we know that all the other guys don't matter, and we're only talking about the global. So bada bing, bada boom, 1, 2.
Right. That makes total sense.
Okay, cool. And then for the second one, names must be declared before use, but the scope of the name is the entire block in which it is declared. Okay, so names declared before use, super easy peasy. Names, our scope is the entire block. So that one's a little tricky. So starting in the, let's actually start on the outer and work in. So names must be declared before use, and then scope is the entire block, right? So the first one, the very first print statement, it can reach that global because it's just in its outer block. Think of the outermost red block. So sure, that one would be fine. But then we hop into the inner one on the print AB on line 11, and we say, okay, B is equal to A on line 5, and we're saying, okay, well, what A is that? Well, we can't really go. We could go outside, but that's not what the computer is going to do. The computer, since it says the entire block is the scope, it's going to check if A3. It's going to look for the A equals 3 in here. It's because it sees that because it's in the block, and so it's going to go, hey, that's declared after. So then it's going to get the error, and that's very similar to this thing in the book here, where in the B setting where it has the declare before use, but the whole block, it's giving an error even though it could reach that 10. It's saying, hey, no, n equals 20 right ahead of me, so I should be using that one. So it's always going to go in the declaration in that block. And if it can't reach that, then it's going to be an error.
So the reason that it's erroring is because there's a declaration later in the block, later in that very block, and
Yes.
that's causing the error. Okay, that makes total sense.
Yes, my only thing though, now that I'm thinking about it, is if that n equals 20 was removed, I am not sure if that would be able to, I would believe that it could get to that 10, but only because that n equals 20 is in that same block, it's having
Right.
issues. But I think if that wasn't,
I think if the later declaration was removed, then it would just be looking back out into the next scope.
okay, cool.
I think, because
Uh,
each variable is defined for the entire block,
Hmm.
and because those, in this case, A and B are being defined at the very beginning, they should be good for the entirety of this function, more or less. And then it's just the fact that inside of an inner function, we have a later declaration, and that's causing the issue. So I think middle would still be able to pull from outside if need be, but because it checks its own block for its declarations, it sees that there's a declaration after it's being called.
I totally agree with you. Does anybody else, like have an objection to that? Or like think it might not be that? If so, that's fine. I mean, open debate is always good. Okay, seems like we're good. Seems like we have a mutual agreement. Okay, C. You want to go over that one? Is that the one you got wrong, Eric?
Right.
Okay, A was the one I got wrong, but we'll go with C. And let's see, names must be declared in any order. So, okay, so we got anything. So there's anything. And then their scope is the entire block. So again, entire block. Okay, so I'm going to work outwards and go inwards, if that's cool with you guys. And I'm going to say, okay, outwards, we're saying A equals 1, B equals 2, and then easy for line 14. That's this guy here in the bottom.
Yep.
That'd be 1, 2, so easy peasy. The next one is going to be on line 11, and that's going to use A and B. So in this one, we're going to go to line 5, B equals A. Okay, which A? Well, it's declaring its entire block. So as Eric was talking about before, it'll check the A that's in its block, and it'll go, okay, A equals 3. So, and it could be declaring any order, so that's good. So B equals 3 in this case, and A equals 3. So then we have 3, 3. So that's this guy. And then we go inside to 7, and this is kind of where it gets tricky. This is the trickiest one. And so in this one, you're using the A and B that go outside of the block. And so you would think for this one that it would just go up, but that since it could be declared in any order, it can also see that A equals 3 there. And so it's seeing the A equals 3 on line 8 because it can be declared in any order. And it's seeing the B equals A on line 5 just because of it can just go outside to its next block.
That totally makes sense.
Yeah, and here I wrote a little thing. It said in the middle, well, you guys can read that if you want. I don't want to waste time with that. But anyway, 3, 3, because basically it can get to the B, it can get to the A, because it could go in any order. If it could not go in any order, I think we already established that in the first one. It would have to go with the B equals A, and then it would have to be the global A.
Right.
Just because A is below both the, well, just A is below line 7. Or sorry, lines 8, which is A equals 3, is below line 7. So that's why it can't even reach that. So that's why for this one it's 1, 1. But for the other ones, since it could be declared whenever, then yes, it can reach that A equals 3 and we're solid. Is that cool?
Yep. That makes total sense.
Cool. I am going to get some water real quick. This is recorded, so like if somebody wants to share their screen and keep going with the PowerPoint or whatever, I will be right back. But my throat is dying, and I don't want to die on camera. That'd be really funny, but I'd like to get some water, so I'll be right back.
Yeah, go for it.
So while he's gone, I'm gonna go a little bit off topic.
Mm-hmm.
So homework 4 is due tomorrow. and I'm mostly done with it, but I'm looking at question 5, and it talks about an inline subroutine. Do you guys know what that is?
He touched on it a bit. More or less what we had looked at is that subroutines can essentially just mean functions in and of themselves. Inline was a specific keyword that is supposed to, I think, like make a slightly different way of compiling it, I think is what I was looking into. But I never got a total answer on that. I don't know if anybody else has any ideas about what inline was actually doing.
Inline function in C. Inline functions are those functions whose definitions are small and can be substituted at the place where its function call is happening. Let's see.
Is that for homework 4?
Yeah, I was looking at question 5, and I wasn't entirely sure what it was actually asking. So
I could totally talk about what it's talking about, because there was a little talk in Discord. I think I figured it out. Jacob gave some really good pages. Once again, Jacob is a really good super dude, a super helpful guy. Excuse me, on Discord, and he usually gives some pretty good stuff. But in the book, there's some chapters. I can list that, but I'll just tell you what it's saying first before I get into that whole thing. Inline functions, they're just talking about functions, and when they say macros, just think of your typical macro. So the big thing against that is normative and normal order application, I think it's called, or something like that. And then the other one is applicative applicative. Let me know if I'm saying that wrong. But one's applicative and one's normal order. And then basically, I'll share my screen real quick, like whiteboard. So for macro, let's say you have like, I don't even know. How about subtraction? So let's do subtract. This is not writing.
I can't actually see.
Yeah, I don't see my. For some reason, hang on. Give me 1 second. Having a bit of an error, it seems. I am trapped in the whiteboard. That's not good. Oh no. My Zoom is frozen too. Can you guys still hear me?
Yeah, I can hear you.
What?
Yeah.
Okay, so my Zoom is frozen, I guess, and my computer is frozen.
It says shared
whoa.
screen, but I don't see anything.
Oh, you're not sharing anymore.
Oh my gosh, my computer just freaked out. That was terrifying. Okay. I don't know if you guys saw that, but I did like a whole exorcist thing because it did like all my movements
Oh,
at once.
okay.
That was scary. Anyway, subtraction. Subtraction. Let's say you do sub x, and you just say, hey, the function of that is, and excuse the syntax. I'm not really gonna focus on syntax, but x minus x, right? Wait, that's a silly example. Let's do add, because obviously sub would always be 0. Let's do add. So in a macro, and remember, inline function is just function. So any function. So if you think of like passing in, the professor gave his own example. So I feel like it's comfortable to say this, but 3 plus plus. The professor was saying, I think he did like square or something, like a function that squared everything. It was just adding. You could say, hey, this is going to do 3, right? It's going to evaluate this and go, hey, we want to do 3 first, and then we want to change it to 4. So like, let's say x equals 3, actually, is a better example. And then x, excuse me, and then x. So 3 will be passed in, and then after, if we printed out 3, this would now be 4. But in the function, it's 3. So it's going to do all the math, and it's going to say, hey, that's 3. And so it's going to do 3 plus 3, and that's going to be 6. So that's solid. In a macro, if you pass in x plus plus, which is 3 still in this case, we're going to say, hey, this is 3 plus 3 plus plus. And so that is going to be 3 still. But now that already happened, this is now going to be 4. So this will get updated because that's the next x. So this is now 4 plus plus. And so that we're going to use 4. And so then that would actually evaluate to 7.
And then x is 5 now.
Yes, and x would be 5. At the end of it, x would be 5 after those two guys. Absolutely. I 100% agree with you on that. And so the tricky thing here is that if you want to say, like, okay, so what would be faster? Like if you did function 3 plus 4 plus 5, let's say, and then we did a macro of 3 plus 4 plus 5, and let's say we just return 1. Like let's say the macro and the function, they both return I don't know, you want to say 3. You could just say a number. You could say 8 if you wanted to, just to make it less complicated. So the function, it'll go, okay, 3 plus 4 plus 5. It'll go, hey, that's cool. That's going to be a number, I don't know. What is that, 12? 12. And then it's going to run it and it's going to go, okay, 8. And then, but the macro, it's going to say, okay, we're going to pass this in. We're going to evaluate it. We're going to actually do the math when we run into it. But hey, we never run into it. So, okay, it's just going to be 8. So in this case, it's faster, basically. I wouldn't use these exact examples, on your homework, but I'm just saying, like, stuff like that. Basically, it's going to evaluate when it runs into it, and it's not going to evaluate the stuff that you don't. Basically, this can be faster in some cases, because let's say that you have the same thing. Well, let's go back to our double function, right? So x plus x, and once again, I wouldn't recommend using x plus x because this is obviously there's a million different examples you could use. Yeah.
Can I ask a quick question? So
sure, go for it.
If I remember correctly, because I was like getting confused. I was like, wow, what's a macro again? Macros are in C. You use the define function, right? Like you do like the pound define and then like whatever the name is and then what it actually does. Is that correct?
Yeah, macros are. Let me show you. Let me see if this has it. Macros are like this. Oh. Yes, perfect. I don't know if you're in CP 301 or because everybody has different schedules, but
yeah, I'm
this
in
is
this class.
defined.
Yeah, exactly. So because like I completely like forgot that you could actually have function like macros. I always were like, oh, these are usually used for constants. So I completely forgot about it. But yeah, no, that's very helpful. Thank you.
Yeah, no problem. And once again, I want to use those exact ones. I mean, the example I was using to tell you that stuff is on, where's that? Right here. And I don't think this goes away. I think it's fine to talk about this because it still has to do with probably what's going to be on the final. Can you see this? Evaluation of function. Yeah, this is exactly the same thing. So they did x plus plus, y plus plus. They talked about that kind of stuff. So yeah, it's basically the same thing. So like for example, this is going to say a plus plus and then b plus plus and then like let's say like x is 3, so it's going to say hey it's 3 right now, but then that's 3 plus plus. So over here it's going to be 4 plus plus, which means that when it returns it's going to be 5 plus plus, and that's just a whole big mess. So basically that's what's happening there. And like here, if you put like y plus plus is 5, and this is going to be 5 plus plus, and then this is going to be 6 plus plus, and then when you return b, it's going to be 7 plus plus. Of course, this is only going to return either a or b, so it's going to happen basically twice to one variable and only once to the other one. Because let's say like 3 is bigger than 2, for example. This is 3 plus plus, and then obviously it's bigger, so it's going to return a. Well, now it's going to be 4 plus plus, and so it's going to actually return 5. Which, if we're talking about what's max, and we throw in 3 plus plus and 4 plus plus, or sorry, 3 plus plus and 2 plus plus, that's going to be wonky. Like, why would we even want that? So in that case, a function is better, because if we did the same thing and did 3 and 2, then we're just going to mess with 3 and 2, and we're going to either get return 3, obviously, because it's the max. But in a macro, it's going to trigger it each time and do the math. Does that make sense? Kind of. I might have just made that way too confusing. Sorry if I did.
No, you're fine. So yeah, the actual homework problem says significantly faster. Like that seems kind of subjective. How much is
I don't know about
significantly
that.
faster? Yeah, I don't
Honestly,
feel like there's a way for it to be that much faster.
No, I think he's just looking for like understanding what's happening, and if we can understand the difference between normal order evaluation and applicative evaluation, that's all he's looking for. Honestly, I just kind of like typed up what they are, like the definitions and like how they would be used and stuff, and I did a couple of I think I did like 2 examples for each question. So like macros faster, I did 2 examples. And then functions fast rated 2 examples, so you could do whatever, honestly. I mean, they're not too hard to think about.
Applicative is what the macro uses, right?
Applicative is what the function uses. So applicative.
So normal order. Okay, so the normal order is actually using the plus plus for both. Okay, that's cool.
Yeah, the normal order is every time you see X, you're doing whatever math is in there. Applicative order is it does it all in the argument and then it just runs with it. It doesn't ever have to do that math again, which can be fast or it could be slower if you're just returning like a single thing, or if you're just returning like, or maybe like an if statement or like a switch statement. I mean, honestly, the possibilities are endless. I think I did like switches on one of them and then like a return on just a variable on the other. I mean, I did like 2 examples, like I said. I can't remember what exactly they were, but yeah. Sadly, I can't give you the answer 100%, but I hope that helps.
Yeah, no, that helps.
And John said something in the chat about incline.
Eliminate time overhead.
Yes. So that sounds right. I did not know that. So thank you, John. I appreciate that information. That is super cool. And I'm glad I filled up my water. Does that sound good to you, Eric? About all that stuff?
I'm pretty sure that makes sense, and I don't disagree with anything that you said. So
I hope that didn't get too into the homework or like,
no.
Cool. Yeah, I was just explaining the difference between normal order and applicative. But yeah, sadly I can't tell you like the exact answer or whatever. But I mean, I'm sure that was pretty self-explanatory. And then John was saying they avoid jumps to a subroutine, which sounds cool. I like how computer science sounds very like technical, like subroutine. Feel like a spy, you know. I don't know.
It makes you sound smarter when you speak about the things that you don't know about, because you use big words that people haven't heard, and then you're like, ooh.
Dude, Kostas and Papa Christos were like they were good. They were good, but I mean they used like syllable count like 7 times. I was like, what are you saying?
I was like, look, I may be in college, but my reading level ain't that high, all right?
Yeah, exactly. Exactly, dude. Yeah, it's crazy. It's crazy.
Is he going over this lecture PowerPoint tomorrow, or what is he doing tomorrow?
I have no clue.
He said that the next lecture would be a review, right, for the midterm?
I hope he goes over this stuff.
Or was he counting that like 5 minutes before the end of last one?
I hope not. I really hope not. Yeah, I don't know. Hey, what's a good ending time for you guys? Do you think 8:15, 8:20-ish?
Yeah, that works.
Think? Okay. If anybody has any objections to that or has got to leave sooner, just let me know. But I mean, technically, I guess you could just leave if you need to leave sooner. But if you wanted to stay later, then just message me in chat. And
Until Thursday at 9 a.m.
Oh, dude, no. but I like your enthusiasm. I feel like you should earn extra credit. You should earn extra credit just for that. Anyway,
We submit this recording as our work for the midterm.
dude, I kind of was gonna do that, but I feel like he just would think that we're, being egotistical or something.
But look, we did it. We know our stuff, right?
Yeah, exactly.
So we don't have to take it.
Yeah, I don't think he would like that too much. I don't know. Maybe. He'd probably think it's cool. I don't know. Where were we on this? I totally forgot. I lost track. We were on homework 3.
I think we were about to get to binding.
We talked about. I feel like we talked about binding in homework 3. We didn't go into like the storage allocation and the we didn't cover this at all. You guys want to cover that? So early binding and late binding. So early binding, basically, I think of it as like global stuff, like static.
Right.
Excuse me. Goodness. Before compile time. So I think before compile time, if I'm correct on this, is literally the compiler doing stuff, because the compiler messes with the source code, makes a target code, and then from there it's all good. Does that sound good to you guys? Or does that sound kind of weird?
Yeah, that sounds right.
Okay. Because I know the interpreter works along with, like I said, he might ask like interpreter versus compiler, so I want to make sure I memorize that.
Right.
But yeah, we got basically some static stuff going on. Doesn't really change throughout the program. The data's locked. Early binding doesn't mess with it. It's fixed basically. And that's why late binding is more flexible, because we got the dynamic stuff going on. We got things changing, and like local variables stuff. Like local variables can change. I think they count as late binding. Correct me if I'm wrong on that.
I believe local variables count as late binding.
Okay, cool. Yeah, and so I would say that. And then object lifetime and binding lifetime. Okay, lifetime, obviously when things live or die.
I think those blue answer, or the blue words there, I think those could be more along the lines of what the true or false questions could be.
Okay. So if an objective outlives its own, that is kind of weird that he did different color highlights. I might have to look back and see if there's a pattern on that. I recommend you guys do that too. If an object outlives its only binding, right, it's garbage. So what would that even look like? That would look like,
so that's I think that's kind of like an empty pointer, more or less.
Right. It's like this. It's like pointing to nothing.
Right.
Okay. And then this one, it's like P is going to something, and then R is going to P. So is R here then? And then R is gone. But P is...
R would be pointing at P, not the actual object.
Gotcha. Sorry. Thank you, Eric.
I think.
No, that sounds right. Because wouldn't it say like and P? It was pointing to the address or something?
I think so.
Gotcha. Okay. And then this dies. I think. Dangling reference.
I think the actual object would die. In this case.
Because R is destroyed, so then P and then?
No, I believe P still remains, but when you're deleting R, you're deleting the object and the pointer.
Could you annotate if possible? That's okay.
Sure. So
thank you.
Go with blue. So I think when we're calling delete R, essentially what it's doing is it's deleting simultaneously the pointer and the pointer to the object and the object in this case.
Mm-hmm.
And at this point, we're still left with the original pointer that was to that object, but now this object isn't even there because we didn't interact with P at all. We basically just rerouted it. And so now we just have a dangling reference from the fact that we have a pointer to an object that's no longer in use.
Gotcha, which is why it says that binding outlives its object.
I think that's what's going on.
That's
Could
not
be
right to
wrong.
you guys? I agree with Aaron. But what do you guys think? I'm gonna take the silence as a yes again. Yes. Okay. Everyone agrees with you, Eric. I think you made a lot of good points. Somebody in chat says I googled it, and he says a dangling reference. I'm just reading this out because I don't know if they're recording as chat. Sorry, this is kind of annoying. But a dangling reference is a reference to an object that no longer exists. Garbage is an object that cannot be reached through a reference. Okay. So I think.
Oh, okay. So in the original one, we're not actually getting rid of the object. We're deleting the pointer, I think. Right?
He marked
Or
that
is
with
that
your.
wrong?
No, I think that's
Garbage is
right.
an
It
object that
says
cannot be reached through a reference. So I think what we're doing in this case is we're deleting the reference P. So we're deleting this, but the object is still there.
gotcha. John, the homie set up a sent a link. I cannot speak today. I'm running out of my words. Sorry, guys. Thank you, John, for your link. Let's check that out. Hopefully it goes. So this looks scary, but it doesn't look too bad. Should we be looking at this? Click more. Click more. Gotcha. This code. Blah blah blah. Okay. So it seems like I'm not going to pretend like I know what's going on here. It looks like we should just read this for a second. Let's see. Yeah. So it says P is a dangling pointer, and it freed P. Output will be garbage. Okay, because it's not pointing to anything. So we freed it from memory, and so now the object is just like it's just there. But it's the thing it's pointing to. It was pointing to a 1. So if we look, I think you were totally right, Eric. So I think if we're talking about here, and John also says the commented code kind of explains a lot. We're talking about the P is going to a 1, and then they freed P, so they got rid of all this stuff, and it says now P is a dangling pointer. Pointer points to deallocated space, which makes sense. This is nothing now. It got deallocated because of free, and so now it's pointing to nothing, and that's why it is. So data at this pointer is garbage. Okay, so we have garbage.
Right, because it hasn't been allocated as anything.
Gotcha. And so if we go back here.
Oh, okay. So you were right then in the first case.
What is this? Okay,
so because we're getting rid of the object in that case, we have a pointer that's pointing at garbage.
Okay, so that's garbage, and then a dangle. So did they talk about dangling references there, or is that the same thing as a dangling pointer? Question mark. I'm not sure. It might be the same thing.
I don't think it's the same thing, and I'm not sure if they're using the word garbage correctly there. I think
might not be.
I think they're just saying that the output of that is going to be garbage because it's just referencing a random memory address.
Okay, but for here, do you think it would be?
I think essentially in this case, like in the case of the actual PowerPoint, garbage is just being referred to any object that doesn't have a pointer to it, in the, like as an overall thing. So it's
like the diagram.
No, get rid of the P and just have a variable.
Oh, please don't.
So like it's memory that's been allocated, but you have no way of reaching it, and so therefore it's just stuck there. So because I think what's happening is that we have an int that's being created with a pointer to it, and then we're taking that pointer completely away. So now we just have somewhere in memory int floating, an int that we had dynamically allocated floating around. And so that's why it's garbage, because it's binding. The only thing that gave us a way to access it is now gone. And so now that object is still there.
Yeah, true.
So
whereas I think that Link was speaking of garbage as just whenever you try to access memory that hasn't been specifically allocated, because you don't know what could show up when you try to access that.
Okay, that was still super useful though. Thank you for the link, John. I appreciate it. but like in this specific context as well, because that other thing was also applicable. But in this case, if he's going to ask a quiz question or like a homework question, excuse me, a midterm question, you're saying that P would stay, and
So
it's not even pointing to anything, right? Is what you're saying?
No, upon creation we have a P which points to an int, and then with the
Yes.
second line, what we're doing is we're setting P now to null
To know.
instead of the int, which
Yeah,
gets
so
rid of this
so that
connection.
new int still exists. There's just
Right.
nothing pointing or referencing it.
Gotcha. So
Right.
this is just in space, and we don't even know where it's going.
Yeah.
Okay. Got it. Thank you, everyone.
And then
Shouldn't
dangling
we-
reference is essentially the opposite.
Isn't P in this case like a pointer though? Like,
Yeah, P in this case
Okay.
would essentially be a pointer.
okay.
So just to reiterate for the
Because
recording.
pointers are just easier to express dangling reference and garbage, but I think when referring to it, when referring to it as a binding, it's also referring to stuff like variable names and all that kind of stuff.
Okay, and then for this guy, we have P, which is going to an int. And then R is pointing to P. Does everyone agree on that? I'm not sure myself. I just want to check.
I think R might just be pointing to the int.
Okay, R is pointing to the int.
Yeah, because it would have to be equal to the ampersand P, I think.
And then delete R.
So deleting R gets rid of R in itself because it's using the delete,
Yeah.
but it also deletes what the dynamically allocated int was. And so now you have P pointing to nothing essentially.
Which is why it's a dangling reference, because it's not.
But you still have the point. Don't
still the
get
point.
that out.
Sorry.
It's just not
Sorry.
pointing to anything specific.
Right. Not B. There we go.
And that's why it would be a dangling reference.
This is solid. Okay.
It's because now you have a reference to memory that's not in use.
Yeah, that looks right to me.
Okay. So an object, when they say object, they're referring to like the ints and stuff.
I
An
think object could
object-
be a lot of different things. It's easiest to break it down in terms of like lower variables like characters or ints. But I think objects can include stuff like functions and all that. But it's easiest to think about the terms garbage and dangling reference in terms of lower variables like integers.
Gotcha. Okie dokes. Does anybody want to go over that one more time, or is everybody good on that? Question mark.
I mean, I'm good on it.
Okay.
I'm
cool.
all good.
Cool. Just to wrap it in my head one more time, because I don't know if I 100% got it. Just gonna say, hey, P is going to the new int, and then P is null. So then that new int is still somewhere in space. So how do we get rid of that new int? Just like delete or something?
Yeah, I think delete would work.
Yeah. Okay.
Delete.
Delete P.
P.
Okay.
Yeah, delete P. Right after it's
Right here.
set equal. Yeah, right there.
Yeah, you would have to delete it before you remove its reference. Otherwise, you wouldn't. I don't think you have really any way of doing it
Okay. Solid.
properly.
And then binding outlives its opposite. So dangling reference, we have new pointer, and then R equals P. So if they're both pointing the same thing, delete R, delete the int in there, and then P is pointing to nothing, garbage, which is why it's dangling, because there's nothing there for it to point to. Which
Right.
The name makes sense. The name kind of like visually, you can kind of see what's going on. It's like a little dangle there, I guess. Arrow. Somebody had a question on. So I'm solid on that too. Thank you guys for your help and clarification. And we'll move on to the next slide after I read what somebody has. So I said, or that Andrew said, question 5. Could you speak it, Andrew? Because
Okay, so we were talking about the inline and functions and macros.
Yeah, sure.
And your example was like if you had a function and you did the increment operation on the variable in the parameter. So like if you had your like function x plus plus, right, or versus your macro with x plus plus. And from the way I understood what you were saying, you said that for the function, it would do the x plus plus first and then take that.
Functions do applicative.
So like if your function were to do like return like the add, like so if it added the variable with itself, right? So if you returned x plus x, right?
Yeah.
From what I thought you were saying, if x was initially 1 and you did x plus plus, it would go to 2 and then it would be 2 plus 2.
Well, no, because the plus plus after
exactly. So I think it was just like I misunderstood because when I actually coded it, it takes
2,
1 as the actual parameter and then
it
increments. It takes the incrementation afterwards. So it returns 2 and then the value is 2. Afterwards.
Yeah, I'm sorry. That's what I was trying to say. I'm sorry if I didn't make that clear. If it was plus,
it's okay. Like I figured it out on my own from coding it, which probably is a better way of learning as well.
Yeah, for sure.
Hands-on approach. So yeah, I definitely understand a lot better now. Your help, you still helped me out for sure.
Yeah, cool. Well, we're just all
I just wanted some clarification. So yeah.
Yeah, gotcha.
That's all for me.
Gotcha. Yeah, no problem. Yeah, but for everyone who was following on that, if they did plus plus x, it would do that first. So it would add it, increment it, and then use it. So like in this case, he was saying you're just doing x plus x and you plug in plus plus 1. Well, that would be 2. And so it would be 2 plus 2, which would be 4. And then if it was 1 plus plus, it would do the 1 first, do 1 plus 1, 2. But then if you called x again, well, that's a bad example. But if you called x again, it would be 2, not because that's what it returned, but because it would be incrementing 1 afterwards. I hope that helps. Sorry, I made that a little confusing. I'm glad you cleared that, and I'm glad you brought it up too. That'll help some people out in the recording, I'm sure. So cool. Thank you, Andrew. Anywho, storage allocation. You guys want to go over storage? Well, let's just go over storage allocation. I'll try to hammer out these couple last ones, and hopefully we'll end before 8:30, and everybody could keep working on what they want to work on from whenever they go to bed. So storage allocation, dynamic, you got your stack or your heap. And so this is kind of where we're talking about he was talking about like cheese, I think, or something. I remember that might sound like crazy. And now I'm saying it does, but he was talking about like this. And he was saying like, it looks like Swiss cheese. I'm pretty sure he did like a thing on cheese, like a joke, I'm pretty sure. And then, so that would be, I believe, explicit. Stack is just stack. Stack is always just vertical. You got your stuff on top of each other. The one that's latest was the latest binding. So if you have like, your global X and then 3, and then you manipulate and you have a local X, then the local X is going to be here, local, and then your global is going to be further down. But for the cheese thing, explicit allocated and deallocated by explicit directives at arbitrary times. Right, so at arbitrary times, it's allocated and deallocated, so it's kind of, you're going in, some memory is going to be there, some's not, I think. Just correct me if I'm wrong on this, but an implicit allocation and deallocation are implicit, transparent to programmer. Now that I'm reading that, I don't actually, I get what it's saying, but maybe you guys have a better diagram of what you think is going on?
Let me see.
Okay. If not, that's fine. But it looks like explicit, it allocates and deallocates by explicit. Well, now I'm just reading it at that point. But you have to specify when it's allocated, deallocated. So that's what we were talking about before. Like we would have to call delete, and we would have to call new. I think that's what it's saying there. And why am I?
I
I
think
don't know why
so.
I'm drawing it, but yeah, you would have to call that. And implicit is like smart pointers, I would assume. Like it just like automatically does it. You don't have to. It's transparent to the programmer. I think like object destruction, like when you're using an object in C++ and then you're done with it, like you don't really have to say destroy the object. I think, in
That
most
sounds
cases.
right. He kind of went over this pretty fast, so I don't really remember too much.
Gotcha.
But that
Gotcha.
does sound right.
Okay, so we'll just say smart pointers, and we'll just say like standard delete and new, and we'll move on with that slide. And we are, as my girlfriend says, we are Gucci, which I think she gets that from her niece. But we'll move on, and we'll say dynamic heap allocation. Maintain a single linked list. Oh, this was the thing with the cheat, wasn't it? Maintain a single linked list.
Yeah, I think more or less this was what you were trying to diagram.
Hey, cool. Yeah, so this is the cheese thing. Awesome. So the first fit is the cheese, and the best fit I think is the just where it's like a loading bar, but this one is like the cheese. So
I
first
want to say
fit
that wouldn't they both kind of be like that?
be
because
the top or the bottom.
Wouldn't they both kind of be like the top in the case that like just thinking with first fit, you just pick the first block that's large enough, meaning that if the first block is filled, the second block is too small, then you go to the next one, and if the third one's big enough, then you could put it in. But isn't that also a case for best fit more or less? Because with first fit, you could end up putting something that's smaller than what the block had. Like the block could be double the space needed, but it's still the first one.
Yeah.
But the best fit, I think you could end up still skipping them if they're too small for the thing that you're trying to put in.
Gotcha. Yeah, I totally agree with you now that I'm thinking about that. I don't know where the heck I got that cheese idea from, but I know I've seen.
No, he did say it. I think it applies to both.
Oh, okay. Yeah, the top one is the cheese, and it applies to both because it depends on how the heap looks, right? So that would depend on like whether you're.
I think it just depends on largely what you're trying to allocate space for, because with first fit, it is just find the first one that is able to fit it. If it's too big, who cares? It still fits. But with best fit, you're just finding where it would best fit into place, which means that you could still skip over areas. Like there would still be empty space, or there could still be empty space, because if you were trying to allocate space for something that was larger than the previous blocks.
That makes sense. So like in this example, like let's say that this was first fit. So let's say like, hey, this first block is huge, but we have a tiny little variable. Well, okay, we're just going to throw it in there because, hey, it fits, so that's fine. But in best fit, let's say we have a tiny little variable, and this is huge. Then we're going to go, okay, no, but then this is super small. And so we're going to fill it in there.
Right.
And so then we would go for the next one. Let's say it's something huge. Again, it doesn't matter. I think this one will always like fill up, won't it? Well, unless it's too small.
Well, it'll always fill up as long as it's as long as it is the size needed or larger.
Yeah, I guess it. Yeah, you're right. Either one could be the cheese, or it could be the progression bar. The progression bar. Excuse me. So yeah, so I think either one. It just depends on which blocks have so much and so size. But I definitely think like just knowing what first fit does and what best fit does is very good. Okay. Does anybody want to still go over first fit, and best fit? Excuse me. If not, we'll just go on. Okay. Separate list for different block sizes. He made like a whole lecture on this, but then he only put this in there, so I don't think it'll be a big thing. But the buddy system, I think, wasn't that the one where like they had them in a row, and then like they had different sizes. Like this was 2 times the size of this one, for each block, and then this one was like 3 times the size or something. That sound right to you guys?
I think
I
that's
honestly
how that was.
Okay, and then for the Fibonacci, it was literally like going by the Fibonacci sequence. And then I think he was saying like if you have a big variable that's like let's say 1.5, or sorry, let's say 3.5, then you can attach one of these guys over to this guy. I remember him saying something similar to that, but I don't want to give you guys wrong information. So
Yeah, I think that's more or less what he was saying. I think it was along the lines of you could take a larger block and split it up into smaller blocks.
okay,
if
gotcha.
need be. If you ran out of space in the smaller block, I think was how it worked. So like
Okay.
if you had filled up the entirety of the 1 section, but you needed to allocate another 1, then you could break up one of the blocks of 2 into 2, and then start allocating 1s to them.
Gotcha. Okay, that makes sense to me. Thank you, Eric. That helps a lot. All right, I'm gonna move on to the next one. And if anybody ever has like anything they want to bring up, just feel free. Statically, lexically scoped, and dynamically scoped. Okay, this is important because this is kind of what our homework was on. So statically, it stays the whole time. Can be determined at compile time. I think this is usually where we're going with the top most level, right?
Right.
Not mistaken. Okay. And then dynamically scoped is like we were saying, it could be shallow, it could be deep. It's always changing. It depends on what kind of stuff you're using. It's always kind of fluid. Excuse me again. And it is kind of you choose the most recent active binding. So that's
I think that's the big one. That's the big takeaway is that dynamically scoped, you use the most recent active binding.
Mm-hmm. And then, so I guess that's different because I guess the subsets of deep and shallow don't really do that. But just like if they say dynamically scoped, then just think of it like that, right?
Yeah.
Or do deep and shallow kind of do that in their own?
I think deep and shallow do that. It's just in the thing that we were doing, it didn't it worked slightly differently just from how we were analyzing the code.
Gotcha. Okay, so let's see. Oh, and there we go. Deep and shallow. I'm not going to go into deep and shallow because we already went over that whole thing. Referencing environment, that makes sense to me. It's just kind of like what we're referencing, what the environment is, what we're using for our variables. So I'm going to skip that one too, if that's okay with everybody. And we're going to go to 61. And static, what is it written? So static, we're always talking about the top. So we're looking up here and we're saying, hey, A is an integer. Well, okay, what is A? And so then we're going to the next thing and procedure first, okay. And then A equals 1. That's global A. Cool. And then we're going down, that's a local A. And then we're going down A equals 2. And then we're writing, but I think we're using the topmost, so we're using whatever's here. And I think that would be how, I think that's why that's 1. But what do you guys think about that? It says refers to the global variable A. There's no local declaration A in first, right? It's global because we're working top down. So that makes sense to me because it's not saying A integer because we're working here, working here, working here. Well, that's global. And then therefore A is changed to global 1. But then in my question is like, why doesn't this change it to global 2? Because I get that this changed it to global 1, but if we're working all the way down, then logically I think this would change to global 2, but obviously it doesn't. So I don't want to confuse everybody on that. It's somehow global 1, but I just am not 100% on why it's global 1. Do you know why, Eric?
Could it be just from the fact that main in and of itself is a procedure? So if you were looking at this as if it was just another procedure, A would be shifting the local variable. A would be acting as a local variable upon running main. I'm not quite sure either.
That's an interesting. Yeah, maybe. That makes sense. That makes, if you think of it like that with that logic, that makes sense because main is just a function in that case. But the way they do it kind of doesn't make it seem like that since it's common.
Right, yeah, because it's like created separately. Mm-hmm. So I'm not really sure. I want to say that it's just because it's the first like actual declaration of it, but I don't know.
That's fair. And then dynamic A in procedure first refers to the local variable A declared in procedure second. Okay, so all it's saying is that A, we have A talking about here, which is local, and then this A refers to this guy, and then declared in procedure second. So this, when A equals 1, they're saying this int A in second equals 1, and then therefore, local A is changed from 1 and destroyed within returning from second. Right, so then A equals 1, and then it's done. And so second is, we're leaving second, and so this was a local variable, so that dies, and then A equals 2. So dynamic makes 100% sense to me, because just like from C, I would know that, hey, we're going in here, we're making a local int, we're going to first, we're setting that to 1, and then we're killing all of this anyway. So second doesn't even matter. I don't even know why we call it second, so A equals 2. So that makes sense to me. Static, a little iffy, but it seems like you work top down, and then whatever the global variable is assigned first from looking top down, that's what it is. And that also seemed very similar to what was that example that we had before?
That is a good question worth bringing up to him, because I want to make sure that it's for the reason of it's the first declaration of the global variable, because I'm not sure if that's like essentially what it's doing, or if there's a different reason for it.
Well, like here it's kind of similar, like static. Are we talking about static? Am I in back? No, static, yeah. So static, like if we're working top down, then boom, that's the first thing. But then, like, yeah, what if this was not int? Yeah.
Well, not necessarily. Oh, well.
I think because
I
if
don't know.
my argument would be if that was just U, then we would just return W. But since it like in the PowerPoint, this is just A, and it doesn't return 2, so it has to be the first thing called. But I totally agree that that's something we should ask him. I'm gonna actually write that down because I forgot to stop. I forgot to keep taking notes. So I'm gonna go ahead and do that and put static PowerPoint number 60. Okay.
Yeah, I just want to know why it's being declared as a 1 originally.
Yeah, and if you guys have any like things you want to bring up on that, feel free to speak up. And yeah, we'll move on to the next thing. There's only 70 slides, so we got only 10 more. We'll be done by 8:30 for sure. I'm pretty sure. Statically scoped languages, hash table, and scope stack. Dynamically scoped languages uses association list and central reference table. Excuse me. That's weird.
So I think this would be more along the theory questions, where they're just kind of giving you a multiple choice about it.
Yeah, I totally agree, because I think that's too much. Like they wouldn't do a problem on that. They would totally. I think you should just focus on the kind of the bullet points. Like just like if they say dynamically scoped association list, just go with the first thing.
Right.
Yeah, but that one I think is just going to be like a memorize on your own thing. And I'm surprised I didn't have that in my notes, which is weird. So I'm going to put that there too. Okay, next. Control flow. We were talking about this. This is pretty recent, so this will kind of be like covering Homework 4 stuff. I had this in my notes because I had it didn't go into detail of what this was. Is this just like left assigned value, so like 3 equals x versus x equals 3? Is that what we're talking about? Because if that makes sense, then I know what they're referring to. But I'm not sure what L values and R values are. But if that's what it is, then
I think it's like x equals 3, y equals x kind of a thing. Wherein x would originally be an L value for the assignment of L equals 3, but then it becomes an R value during the next assignment.
Gotcha. Okay. So R values usually impact left values, if I'm not mistaken.
I believe so, yeah.
Okay, cool. All right, I'll stop on that. And then expression-oriented and statement-oriented. So that was another, he didn't really go into detail on this review session here and the rest of the slides. He didn't really talk about that. But it seems like expression-oriented is more, I don't know, I feel like statement-oriented would just say what the answer is. It wouldn't do like a big like expression, like checking if it's that or something. What do you think, guys, in general?
I'm not sure. He like the fact that he didn't give an example of what statement-oriented language even really refers to
Makes me think that's
makes
not
me really confused.
Okay. Yeah, towards the end of this, I kind of got, because it's more modern. You know, it's more of the stuff that we haven't been
Yeah.
hammering on for the past couple of weeks. So, 65. Oh, value model and reference model. I think value model is just like the value, obviously, and then the reference is like just the address of what that's referring to. I could totally be wrong on that, but I just think from value and the
Yeah, that
keywords
sounds
here.
correct.
Okay, cool. Order of applying operators. So this is just example of what controls the flow of operations. So we have PEMDAS, which is, you know, depending on, like if you have 6 plus divided by 3, 6 plus 2 divided by 3, there you go. Then it would do one over the other, like precedence, right?
Right.
And so order evaluating, so it evaluates in certain ways. The compiler reorders stuff, so it works with it, probably like a post order or pre order kind of math. Short circuit evaluation, that's kind of what we were talking about in the homework. Basically, if you have one variable, so let's say you have, give me some variables there if you don't mind. Like 3.
How so?
Ones. Just like letters.
Just A and B.
A, B, okay. Let's do A, B, C, sure. And so we're going to say, hey, A is 1, and let's say we're anding these guys or something. That's not supposed to happen. Let's do ABC, and then let's say like this statement is an if statement with gobbledygook in it. If this returns true, it's always with Boolean stuff. So it's either going to be 1 or 0, true or false, however you want to think of it. So if this returns true, and we're anding it with all this stuff, then hey, we can ignore all that. And then if we're oring with all this stuff, we can ignore that because 1 ORed with anything is 1, and 1 anded with anything, you can't really tell what it is. You have to get this very cool. So if that's a 1, then it's a 1. If that's a 0, then it's a 0. But if it's if it's 0, anded with an X of anything, then it's always going to be 0. And so that kind of, it determines what A is or X, or if it was X or Y or Z. It determines what X is. If it's 1, cool, this whole thing's 1, and it doesn't need to evaluate the rest. And this is super important if you're thinking of like each X is like a switch statement or like a big long, kind of thing. So anyway, that's my 2 cents on that. Does anybody want to bring up more on that topic, or have a little bit more confusion on like go-to and stuff? Because go-to just kind of breaks out of we can think of it as like C++ breaks out of the loop, goes out of the loop, goes to the global, hops around lines, basically moves you around.
Or just the assembly jump, which is the easiest.
Yeah, assembly jump, absolutely. Yeah, it's kind of the same. I think that is that like technically the exact same thing, or is it like the same thing? It does the same.
It's essentially the exact same thing. It's just
gotcha.
I think well, obviously assembly is like such a lower level thing, so jump is, I think, easier to actually jump between things when using assembly, whereas goto, I think the specifications are way more in depth in most higher level languages, which is, I think, the large reason of why people say not to use it in most cases.
Okay, for sure. Yeah, that makes sense because I'm still thinking of what you were saying. If you use jump, then that could be super dangerous because you don't know where you're going really.
Right.
This thing, right? So this was like if it's in a range from 3 to 5, then it's C. If it's 2 or 7, then it's B. So this is just a switch. And then he was saying, hey, assembly language, we could either do sequential testing or we could use a jump table. Sequential testing is like if else kind of thing. So it's like breaking each of these up into an if else. So you can think of like if 1, then A, if 2, then B, but like in assembly language. And we top down the jump table because it mentions it right there. Except that's the end of the reading, which is a little weird because I remember. Oh man. Okay. Mentally note that is 66, and then we will go down here to the jump table. There it is, right there. No, there it is. No. Sorry, guys. I forgot he didn't put it like right there. I know where it is though. I know it's definitely in this lecture. Okay, so here's a sequential. So basically, I think this is. Oh no, that's falling through. Excuse me. This is the jump table. So jump table. We immediately hop over to 6. So it says go to 6. So we go to 6, and then this is where the jump table begins. So I think question wise, he won't have us like make one of these, but he'll definitely have it like, yeah, he'll be like, is this sequential or is this a jump table? Basically, this is a jump table because what it's doing is it's listing out everything, and then but it's going here to L6 first. So it's checking, hey, the expression, and then is the expression itself less than 1? Or if it's greater than 10, they're both going to go to L5, which is the else, because none of those other ones are less than 1 or greater than 10. And then otherwise, it's going to set that to, I don't know what that minus does, but I know this for sure will go here to T, because this is T, and so it's going to get the T element, so it's going to say, hey, it's going to look through this, and it's going to go, hey, L5, and that's why it's dereferencing whatever you pull out of here from the hat, and it's going to go to L7 because it'll already be there at L5 or L4, and this is basically the same thing. So then L7 is going to go there, and once again we said like L5 for example. So if this is L5, which we called here, it's going to get dereferenced. It's going to go to L7. We're going to go up here, and then we're going to go, hey, go to L5, and that's going to be clause E. Oh, that's a terrible example. Sorry, guys. L2. Yeah, let's say it's 7. L2. Dereferenced L2. Goes to L2. Clause B. And then it goes to L7. And then we're done.
Right.
Gotcha. Okay. Sorry if I confused somebody there. Anyway, sequential is just kind of like going step by step. Back to 66. Because we're almost done here. We got 4 more slides. Next, mechanisms. Enumeration control for loops. 4. We're very familiar with 4. It's just gonna, like printing out an array. It's just gonna go over each thing. It's gonna evaluate it a certain number of times. Go over. While it's while and do while, we have a bool that's controlling it. It's gonna be do this until it's true. While it's true, do this. We're very familiar with that kind of stuff. If not,
he had brought up that both, like in I think C++, both were technically logically controlled, if I'm remembering correctly.
That confused me. I didn't understand that. That he said both are logically controlled.
I think that's what it was, because you can't have. I don't think you can really have a while loop that's well defined in terms of enumeration control. You can have like something incrementing just inside.
Yeah.
But there's no real reason to, unless you're looking for the exit case.
Yeah, the while loop makes sense for me. While loop in my mind is always logically, but I don't see how for loop is logically. He did say that for sure. But in my mind, I guess you could do like a break statement in a for loop. But then I guess he's assuming, I would assume when he said that, he assumed all for loops, or he's saying all for loops.
I want to say that it's because the for loop is essentially creating a Boolean check when it increments its variable, but I'm not sure.
Like in the
That's the
assembly
reason.
language, like in this for wait, that's not an example. I have to go all the way back. Hang on. 1 sec. This no, this one. Okay, so like in this one where it's saying, hey, no, because even that one it's increment. Well, and this is saying if this, then go to. Is that what you mean? Or not really?
Kind of. I'm just thinking of like in terms of C++ when you're making the for loop, you're basically having a variable that's being incremented, and then you're doing the loop up until it reaches a certain point.
Mhm.
And
And
so
then it
like
says if it's
it's
that.
essentially like checking that it's still within bounds, I guess. I don't know. I don't remember what he was really talking about with regards to for loops being able to be logically controlled.
I'm going to note it because that sounds very important. I'm going to put 4 with C because these are questions we can ask. I think the main point of this lecture, this semi-session, was to get out some questions we could ask him.
Right.
Go over generally what's going on and then form some good questions. So yeah, I totally agree. Because in my mind, for loop, I mean, it's still executed. Like let's say you do 4 I equals 0 to 10. It's still going to execute 10 times, which in my mind would be an enumeration because you set how many times it's repeating. But like you said, we should totally check with him, and I agree with you on that. Tail recursion. I feel pretty good on tail recursion.
I feel good on the theory. Making them is like
mood. Feel good on the theory. Not so sure about making them. Does anybody want to talk? I want me to talk a little bit about like tail recursions or what's up with that?
I think we're all good.
Okay, cool. Evaluation. We talked with me and I think Andrew talked about that. So we brought that whole thing up. We talked about that, and we are done. Yay! My throat hurts so bad. I don't talk at all, like because I'm stuck in my room all day basically.
Yeah.
But that was fun actually. Well, guys, is there any final questions you want to bring up before we bring a close to this fun session? And sadly, we can't go up until 9 a.m. like John was saying, until Thursday. We can't do that. We're gonna have to end here. But it was fun hanging out with you guys.
Yeah,
that was really helpful. Thank you.
Yeah, absolutely. We're all just helping each other out, and I know like this is the first time, so we got this is the first time that we kind of all met each other over Zoom, I guess, like personally. But hopefully as the semester progresses, we could get a little more open with each other, and we're all just learning together. I said wrong stuff. I still am iffy about some things, and thank you for helping me. So I appreciate you guys coming here.
Thank you.
Yeah. All right. Well, I'm gonna end the recording and send the recording on Discord, or I guess send a link or something. I might send it to Professor. What are your guys' inputs on that? Because I want to get your permission before I do something like that.
I don't mind. I just don't know what he would say about it. I don't know if he would care.
I don't think he'd care either. I think he might be like, "Oh, it's cool," but Andrew, you cool with that?
Go for it.
Sorry, what?
Hey, are you cool if we send this to the professor too, or just Discord?
I don't care.
Okay, cool.
I don't care. Yeah.
Cool. So just wanted to get everybody's okay before we do that. So cool. I'll send that to Professor too. Just be like, hey, we did a thing. Did we even talk about the right stuff? Are we in the right direction? Yeah. Thank you very much. Have a good night, everyone. I'm going to end the recording and end the call here, and see you guys around.
Thank you.
Have a good night.
All right. Good night.
Good luck on the test.
See you guys.
Good luck.
Good luck, guys.